Okay, so these are parabolas. One is a function, one is not a function.
Oh.
And we're going to talk about the vertical line test. Anybody remember the vertical line test? Okay.
I can tell you what it is.
Mm-hmm.
So like, you like to see if something's a function or not. You put a vertical line going this way. That's how vertical is. Like this way, and if it touches 2 points, then it's not a function.
Okay, so we're going to draw a vertical line. He did a great job of explaining it. How many times does it hit the graph? Once. Okay, we're going to draw another line. How many times did it hit the graph? Once. If we keep drawing lines, how many times did that line hit the graph? If you draw a vertical line and it hits the graph once, this is what we call a function. And what we just used was called the vertical line test. Okay, so this is a function. We can keep drawing lines for days. It's only going to hit the graph in one place. Okay, what about this one? If I draw a line, how many times does that line go through the graph? Right here and right here. So because that vertical line hits the graph in 2 places, you guys, as soon as it hits 2, okay, 2 or more, this is what we would call not a function. And what I just did for you guys was called the vertical line test. You can use a pencil, like when you're doing your graphs, you can use your pencil as your vertical line and test it. Yes. What? Mm-hmm. Okay. We're going to use our workbook page, and it's going to be page 13. I'm going to show you what I want you guys to do. So we're going to do the domain, the range. We're going to look at a couple different ones on here, okay? So, can I take the vertical line test off? Okay, so this is a mapping. And what I want you to do, and this is what we'll be doing later this week, we're going to state the domain, the range. We're going to state whether it's a function or not, and then we're going to state whether it's one-to-one or onto both or neither. Okay. So I want to show you how you do the domain. So you would write D, and then you would do that set, the brackets. Whenever you go to write your domain or range, you're going to write it in order from smallest to largest. That is the correct way to do it, okay? When I taught algebra, I probably didn't harp on that, but now we're in Algebra 2. I'm gonna tell you about it. Okay, so the smallest number of the domain is 100, 200, then 300. That's our domain. We're going to do the same thing with the range. Again, when we go to write the range, you're going to put it in order to smallest to largest. You guys, most of the time if you do a mapping, the mapping is going to be from smallest to largest. Now, the definition of function. When we defined function, we said is a relation in which each element of the domain is paired with exactly one element in the range. So the domain is paired with exactly one element of the range. Is that true? 100 goes to 50, 200 goes to 100, 300 goes to 150. So this is what we call a function. And because each element of the domain has exactly one element in the range, this is both an one-to and an onto. Too big. Can you see that back there? I'm not going to be able to get much bigger, I don't think. Okay, you ready for the next one?
Miss 3. How can you tell if it's a function or not whenever?
Because each element of the domain has exactly one element in the range.
So one shares one, then it's not a function.
Correct.
Gotcha.
So we're actually about to do one that's not a function. Okay, what is the domain? 3 is the domain. What is the range?
1, 5.
Now, the domain does not have exactly one element in the range, right? The domain has 2 elements in the range, so that means this is not a function. And if it's not a function, it cannot be 1, 2, on 2, or both, so it is neither. So we stated the domain, we stated the range, we stated whether it was a function, and then we stated whether it was 1, 2, on 2, both, or neither. Again, you guys, as soon as you write it's not a function, it's neither 1, 2, or on 2. Okay. Number 3, what's your domain?
1, 2, 3.
What is your range?
2, 4, 6.
Okay. Does the domain have exactly one element in the range?
Yeah.
So 1 goes to 2, 2 goes to 4. So this is what we call a function. And is it 1 to 1, on 2, or both?
1 on 2. 1 to 1. That's what it's both.
Because there's exactly one element of the domain and exactly one element in the range, then it's both of them.
Wait, what's the difference between 1 to 1 and on 2?
1 to 1 means that you might have an extra element in the range, or 1 goes to 2, 2 goes to 4, 3 goes to 6. I mean, that's basically 1 to 1. But on 2, 1 might go to 2, 2 might go to 2, and 3 might go to 2. That's on 2.
Oh, so when they match up, that's 1 to.
Mm-hmm.
And whenever it's 1 to 1, that's whenever there might be like leftover.
Yeah, you just have one leftover range.
How's it both?
Both, because everything matches up. Like everything in the domain has one element in the range. There's nothing repeating. So if you always have one element in the domain and it matches one element in the range, then it's always going to be both. We'll do one that's just 1 to 1. Okay. Now, the circle. We're going to talk about the domain and the range, but let's start with basically, is it a function or not?
No.
It's not a function because if I put my pencil there, my pencil goes through the top and the bottom. So this is not a function, which means it is neither of those options. But now what we need to talk about is that domain and that range. So remember what the domain is. The domain are the x values, okay? So we're going to look along the x-axis. So we're going to look here. So what is the range of the x values on the x-axis?
-2 to 10.
Okay, -2 is going to be on the y-axis. So we're looking right here. So what's the smallest number?
2 or 0.
0, because 0 goes up here, right?
Yeah.
So we're going to write x such that x is less, 0 is less than or equal to x, which is less than or equal to, what's the largest number on the x-axis? 10. So our x coordinates are going to be anywhere between 0 and 10. Oh, I'm so sorry. And then the range is going to be y such that, so what's the smallest y that you see? The smallest y on the y, -2, is less than or y, which is less than or equal to. Right now, your domain and range is going to be very specific. It's going to be contained to what you see on the graph.